Good day everyone. We are group 4. Now we are discussing about array data structure. First of all, what is an array? Array is an index sequence of components. Typically, the array occupies sequential storage location. The length of the array is determined when the array is created and cannot be changed. Each component of the array has a fixed, unique index. Array works as collection of items. You can use them to gather items in a single group and perform various operations on them. Array index. Array indices and integers. The bracket notation AI is a use bracket operator performs bounds checking. An array of length n has bounds of 0 and n to 1. Any component of array can be inspected or updated by using its index. Array elements. Arrays are homogeneous, however, an array of an object type may contain objects of any subtype of that object. For example, an array of animal may contain objects of type cat and objects of type dog. An array of object may contain any type of object.
Hey everyone, I am Rolian Ayardo and I am here to explain our example program. As you can see on the presentation, use the for each loop because it is the easiest among the others. For loop is good with arrays as well. For instance, if you need to count each item like this, the for loop is good with arrays as well. For instance, if you need to count each item, it's actually very simple. We use the length property of the array to decide how many times the loop should iterate. And then we use the counter variable I to output where we are in the process, as well as get the item from the array. Just like we use a number, the so-called index, to put items into the array. We can use it to get a specific item out again. The array class contains a bunch of smart methods for working with arrays. This example will use numbers instead of strings, just to try something else, but could just as easily have been strings.
Fixed size. Gamit siya upang makakuha ng halaga na nagpapahiwatig kung ang array daw ba ay may sariling firming laki or wala. Is read-only. Ito ay ginagamit upang suriin kung ang array daw ba ay binabasa lamang o hindi. Is synchronized. It is used to check that access to the array is synchronized or not. Length. It is used to get the total number element in all the dimension of the array. Ginagamit ito upang makuha ang kabuuang elemento ng numero sa lahat ng mga sukat ng array. The long length is used to get a 64-bit integer that represents the total of elements. Rank represents how large element is. Rank is an integer starting from 1. The larger the element, the larger the rank. If two elements are equal, the rank must be the same. Sync_root. It is used to get an object that can be used to synchronize array. It's an internal object a class uses to allow multiple threads to access and share its data. Some classes expose the sync_root object so that client code can also gain exclusive access for operation that needs to be atomic. As read-only. It returns a read-only wrapper for the specified array. If you just return an actual list as a read-only list, then the caller can also just cause it back. And then modify the list as they please. Conversely, calling as read-only creates a read-only wrapper of the list, which consumers can't update. Binary search. It is used to search a range of elements in a one-dimensional sorted array for a value. Binary search, also known as half-interval search. Search or binary chop is a search algorithm that finds the position of a target value with a sorted array. Binary search compares the target value to the middle elements of array. Clear. It is used to set a range of elements in an array to the default value. Clear method is used to remove all the elements from a set Using the clear method only clears all the elements from the set and not deletes the set. In other words, we can say that the clear method is used to only empty an existing set. Clone. It is used to create a shallow copy of the array. Clone method. Object cloning refers to the creation of an exact copy of an object. It creates a new instance of the class of the current object and initializes all its fields with exactly the contents of the corresponding fields of this object. The copy method, it returns a copy of the elements. We can copy a set to another set using the equals operator. However, copying a set using equal operator means that when we change the new set, the copy set will also be changed. If you do not want this behavior, then use the copy method instead of equals operator. Copy to array. Copies all the elements of the current one-dimensional array to the specified one-dimensional array starting at the specified destination array index. Create instance. Creates a multi-dimensional array of the specified type and dimension lengths with zero-based indexing. The dimension lengths are specified in array of 32-bit integer. Empty method. The method is of Boolean type and returns true if the stack is empty, else false. Parameters. The method does not take any parameters, return values. The method turns Boolean true if the stack is empty, else it returns false. Finalize. The finalize method is used to perform cleanup operation on unmanaged resources held by the current object before object is destroyed. The method is protected and therefore is accessible only through this class or through a deliver class. Find. Find method searches for an element that matches the condition defined by the specified predicate and returns the first occurrence within the entire array. Index of array. The index of method returns the first index at which a given element can be found in the array or -1 if it is not represented. Initialize. Initialize methods is part of the object creation process in Ruby and it allows you to set the initial values for an object. In one another programming languages, they call this a constructor. For example, let's say that you have a point class. This point needs two coordinates, x and y. Reverse. The reverse method reverses an array in place and returns the reference to the same array. The first array element now becoming the last and the last array element becoming the first. In other words, element order in the array will be turned towards the direction opposite to that previously stated. Sort. Sort method, the elements of an array in place and returns the reference to the same array now sorted. And the default sort order is ascending built upon converting their sequence of UTF-16 code units value. ToString. This method is used to transform an object into string. Typically, it is used to construct a string containing the information on an object that can be printed and we can redefine it for certain class.
Multidimensional arrays. A multidimensional array in C# is an array that has more than one dimension, such as two-dimensional array or a three-dimensional array. The number of dimensions in an array is known as its rank. In C#, there are two types of multidimensional arrays, rectangular arrays and jagged arrays. A rectangular array is a multidimensional array where all the rows have the same number of columns and all the columns have the same number of rows. This means that each row and each column of the array is the same length. Rectangular arrays are created using the new operator and a set of comma-separated dimensions inside the square brackets. A jog array is a multidimensional array where the rows may have different lengths. This means that each row of the array can have different number of columns. Jog arrays are created using an array of arrays where each inner array represents a row of the jog array. A two-dimensional array, also known as a matrix, is an array with rows and columns. It can be thought of as a table, where each element in the array corresponds to a cell in the table. A two-dimensional array is created by using a comma inside the square brackets to separate the dimensions. A three-dimensional array is an array with three dimensions, such as a cube. It is created in a similar way to a two-dimensional array by using a comma inside the square brackets to separate the dimensions. In this first example, the code in bracket, comma, bracket, r equals new int bracket 3, comma 3, bracket, colon, declares and creates a two-dimensional array of integers in C#. The int bracket, comma, bracket part of the code specifies the type of the array, which is an array of integers. The type of an array includes the type of the elements it contains, in this case, integers, as well as the rank of the array, in this case, 2 for a two-dimensional array. The R part of the code is the name of the array variable. This is the name that is used to refer to the array in the code. The new int bracket 3, comma 3, bracket part of the code creates a new two-dimensional array with 3 rows and 3 columns and assigns it to the R variable. The new operator is used to create a new instance of the array, and the dimensions of the array are specified inside the square brackets separated by a comma. After this code is executed, R will contain a two-dimensional array with 3 rows and 3 columns, and all the elements in the array will be initialized to their default values, in this case, 0. You can then access and modify the elements of the array using a pair of indices, one for the row and one for the column. In the second example, the code in bracket, comma, bracket, r equals new int bracket 3, comma 3, comma 3, semicolon, declares and creates a three-dimensional array of integers in C#. The int bracket, comma, bracket part of the code specifies the type of the array, which is an array of integers. The type of an array includes the type of the elements it contains, in this case, just like the first example, integers, as well as the rank of the array, in this case, 3 for a three-dimensional array. Just like the first example of the code, the R part of the code is the name of the array variable. This is the name that is used to refer to the array in the code. The new int bracket 3, comma 3, comma 3, bracket part of the code creates a new three-dimensional array with 3 layers, 3 rows, and 3 columns, and assigns it to the R variable. The new operator is used to create a new instance of the array, and the dimensions of the array are specified inside the square brackets separated by commas. After this code is executed, R will contain a three-dimensional array with 3 layers, 3 rows, 3 columns, and all the elements in the array will be initialized to their default values, in this case, 0. The code provided in this slide is a C# program that demonstrates the usage of a two-dimensional array. The program does the following. 1. Declares and creates a two-dimensional array of integers called R with 3 rows and 3 columns. The array is created using the new operator and the dimensions are specified inside the square brackets. 2. Initializes some of the elements in the array with values using the array indexing syntax. For example, r bracket 0, 1 bracket equals 10 assigns the value 10 to the element at the first row and second column of the array. 3. Uses a nested loop through to traverse the array and print the values of its elements to the console. The outer loop iterates over the row of the array and the inner loop iterates over the column of the array. For each element, the program uses the console.write parentheses method to print the value of the element to the console, followed by a space. After the inner loop completes, the program uses the console.writeLine parentheses method to print a new line to the console, so that the elements of each row are printed on a separate line. After the program runs, it will print the values of the elements in the array to the console, separated by spaces, with a new line at the end of each row. For example, if the array is initialized as shown in the code, the output will be what was in the feature. So, multidimensional arrays are an important data structure in C# because they allow you to store and organize data in a tabular form. They are particularly useful when you need to represent data that has more than one dimension, such as matrix of numbers or a table of values. One example of a real-life application of multidimensional arrays is an image processing, where images are often represented as two-dimensional arrays of pixel values. The pixel values can be stored in a two-dimensional array, with each element in the array representing the column of the pixel in the image. This allows you to manipulate the image by modifying the pixel values in the array. Another example of a real-life application of multidimensional arrays is in scientific data analysis, where multidimensional arrays can be used to store and analyze data from experiments or simulations. For example, a three-dimensional array could be used to store the results of a simulation that involves three variables, with each element in the array representing the value of the simulation at a particular point in space. In general, multidimensional arrays are a powerful tool for storing and manipulating data in C#, and they have many practical applications in a wide range of fields.